SwayamPrabha. Digital India. Educated India.
So, welcome to lecture number 8. This lecture is more focused towards composite manufacturing process. In the last lecture, we went into a concept called design for manufacturing, wherein which we kept manufacturing as one of the theme, and then we went back and tweaked our design process, designing of a component, and then trying to reduce the number of parts, making all the assembly in one direction, and all the suggestions were made. So, now with that idea, let us try to move into manufacturing of composite processes. So, in this lecture, we will try to see some classification of manufacturing of process of composite process. Then we will see two major processes. One is hand layup, the other one is spray layup process. When you are looking into manufacturing, process is classified primarily into three types. One is called as parts for structural application, parts for semi-structural application, and part for non-structural application. Non-structural application, I always used to refer it as secondary structural applications. Non-structural applications means they don't take heavy loads, they just give a covering, protecting, a coating or a box closure. So, here predominantly we always go for discontinuous fiber. Discontinuous fibers can be like you take a long fiber, cut it into several small pieces, and then stack them in some in a non-aligned fashion or in an aligned fashion to just fill the space. When I talk about structural applications, the fibers are aligned in the loading direction. So, this will try to give you a major lead to decide which process to choose such that you can meet out the customer requirements. So, just a recap of arrangement of fiber, and so you can have unidirectional fiber orientation. This unidirectional fiber orientation is predominantly used for taking the loads. So, if you look at it, there are processes as of now you just and get exposed to these processes names, and then later in the presentation we will go through all these processes. When you have a load taking composite for structural applications, you will have unidirectional fibers oriented in the direction of loading. So, this will lead to two processes called as continuous pultrusion process or compression molding process. When you have bidirectional orientation, the reinforcements are continuous strand roving, you can have filament winding process or compressive molding process. So, here we use oven fabric or oven roving, and the process predominantly used for this are hand layup process. Today we will see what is hand layup process. You can also have multi-directional fiber orientation. So, that means to say the fiber are oriented at several directions. This the reinforcement type can be chop strand mat, continuous chop strands and chop strand mats, and then you can also have triaxial fabrics. To get more idea about this, we have already discussed in the fiber reinforcement forms all these orientations. So, here what I am trying to insist is you look at what is the orientation you have, then you can see different processes involved for making a polymer matrix composite. For more understanding and visual from the visualization point of view, you can see this is a continuous fiber, this is a continuous fiber oriented along the pipe. This is a chop strand. So, the continuous fiber is broken into several small fibers, short fibers. If you look at it, this does not follow any uniform pattern. It is just cut a fiber is cut into several small pieces, and they are all mixed and blunt inside the polymer, and it is extruded here. This figure is only to give you a comparison between continuous and chopped strand mats, which are cut into pieces and then mixed with the polymer. So, now you can easily understand along the loading direction what will be the load taken by the fiber matrix, along the load direction what will be the load taken by the fiber and matrix. So, here the fiber cannot take major load. So, it is going to be more towards secondary structural applications. So, if you see the classification of FRP, that means to say fiber reinforced plastic, and here we can use either glass / carbon / Kevlar for our application. So, they are divided into thermoset composite based upon the matrix, thermoplastic composite, then it can be short fiber composite, continuous fiber composite, and here in short fiber composite you have injection molding process, compression molding process, liquid molding process and spray up molding process. When you talk about continuous fiber composites, you have layup process, filament winding process, liquid molding process and pultrusion processes. So, when you talk about thermoplastic, the difference between thermoset and thermoplastic is here the thermoplastic, the viscosity is very high. Viscosity is high. So, when the viscosity is high, so it has to be injection molded. So, you see predominantly it will be injection molded or compression molding. So, where we use pressure to give a shape to it. You can also have layup, thermoforming process and compression molding process. These are some of the processes which are under the thermoplastic composite fabrication. So, to have more about thermoset. So, first our focus is more towards thermosetting process. So, thermoset setting process matrix composite. We have hand layup process, spray up technique process, filament winding process, pultrusion process, resin transfer molding and autoclave. These are some of the processes which we will try to cover in this lecture series. So, today's focus is more towards hand layup and spray up techniques. When you talk about thermosetting polymer, thermoplastic polymer, we will go through injection molding, film stacking, drab forming and thermoplastic tape laying processes. When you have to decide the process, you should also keep in mind what should be the annual quantum of what is the annual requirement of a particular product, because this requirement, annual requirement will help you to decide a process. Why is this very important? Because the right process will give a high quality output, the right process will also make my costing economical. So, first we have to understand what is the product, then what will be the annual requirement of the product. If you see here, I have classified aerospace, I have consumer appliance, I have classified everything. So, you can see for consumer appliance, it will be predominantly non-structural composites are required. When you are looking for aerospace, we also always look for structural applications. So, here these are the processes which are involved for making it. If the quantum is very low, we go for hand layup process. If the quantum is slightly higher, we go for mold. We also go for resin transfer molding. We go for pultrusion process. Pultrusion is nothing but pulling plus extrusion, pultrusion. We also do filament winding process, but if you want to do filament winding process, the performance will be very high, but the quantum cannot be very large. Then autoclave process. Predominantly for aerospace applications, we use an autoclave for producing high performance components. So, based upon the annual requirement also is one of the factor you decide which process to choose. So, here are again the volume versus performance. So, here we have put wet layup process and then we have put resin transfer molding, short fibers when the production volume is for short fibers, thermoplastic composite, advanced RTM resin transfer molding, and we also have something called as prepegs. Prepegs are nothing but ready-madely mixed. It is a ready-made mixture of resin and glass fiber or fiber form. It's ready-madely available, something like a Dove or something like a laminate is there, so where in which the resin is already there. They have a top and bottom thin plastic covering so that it does not get cured. So moment you wanted to cure it, so what you do, you remove the top and bottom layer, plastic thin sheet, and then stack them depending upon your orientation, keeping the final outcome required, and then you apply pressure and heat, so you make a composite out of it. Let us look into hand layup process. Before getting into hand layup process, I would like to tell you one more small point from the manufacturing side, which will help us to decide which process to choose. Take any product. When you take any product, first you should look for what are all the functional parts and what are all non-functional parts. That means to say, functional means the part wherein which there is certain function expected, and I am more worried about their dimension accuracy, finish, everything. And a non-functional part is a part, or a non-functional surface is a surface wherein which I am least bothered about the dimensional accuracy and the finish. For example, you take this component, I need a smooth surface, I need a hole, but I am least bothered about the dimension of the hole. I am least bothered about the internal finish of the hole. I am worried about the external finish of this product. So now this is a functional surface. This internal surface, not such an important parameter for me. So those internal surfaces are called as non-functional surface. These are called as functional surface, wherever I need to maintain a dimension and I need to maintain a smoothness. So based upon this functional and non-functional surface, you will also decide to choose whether to go for an open molding process or for a closed molding process. Open molding process means you will have one bottom to give the shape, and you will not bother about the top surface. For example, a lid which is used in a container, we are only worried about the top surface. The bottom surface we are not so much worried about. So bottom surface of the lid is called as non-functional surface. For example, you take a boat, we are more worried about the boat outer surface rather than internal surface. Internal surface we can always cover it with a top wood or some other plank, so that it does not matter much. So that is also one leads statement for deciding the process, whether you need what are all the functional surface in the product or in the part, and which process to choose for that. Okay. So hand layup is one process which is in open mold process. So wherein which the one surface, we are more focused towards only one surface where you want to have a smooth surface finish. So hand layup is an open molding open mold method for shaping to give a form to a structure. Since the layers are laid in a direct contact with the atmosphere, it is called as open mold process. Predominantly open mold process is manual process. So here the fibers are manually laid. Moment the fibers are manually laid, so what? The production rate is low. Production rate is low. Okay. And second thing is, but the advantage is it gives me lot of flexibility while building a component, while building. For example, I can try to put an integral part inside. I can try to, if at all I make a mistake, I have a possibility of tweaking it. And since I always use my hand, the most flexible and controllable gripper ever made is our hand, wrist. So I have lot of flexibility to move my hand and try to get the required form for it. So any type of fiber can be used. Generally what we use is glass fiber. Carbon fiber can be also used. Kevlar fiber can also be used. So here the matrix will always be thermoset, and this matrix will be in the liquid form. Suppose if it is in the solid form, we heat it to a temperature, convert into liquid, or there are straight available off the shelf liquid form thermosets. So we take that resin and add the ingredients such that I get the required output. the mold has a shape of the product and the product has a better surface finish over the side that is in contact with the mold. That is what I said, functional surface. So, only one surface will have a very good surface finish and it tries to take the shape. The other side, the opposite side of the mold surface or the product which is not in contact will never have a good surface finish, but you can, if you are in if you want, you can also get it done. So, if you see that these are the processes. So, here the first process is you try to make, this is a mold, this is a mold. So, in a mold first what you do is you try to put a releasing agent. You try to put a releasing agent. So, the releasing agent is basically to make sure the product does not stick with respect to the die or the mold, and then this so that the mold can be reused for several for making several products. So, first you try to do a degreasing, or first what you do is you just give a small greasy coating such that it does not stick. Even before doing greasing, you do first degreasing to remove all the impurities on the surface, wash it, clean it with acetone, and now the mold is ready. So, you can have a flat mold or you can have a confined mold. That's depending upon the requirements. So, then you try to put the greasing agent so that it helps in rebel removing. Then you give a gel coating to it. Gel coating makes sure that the surface, the composite which is in contact with the die will always have a smooth surface finish. In the gel coating, you can also add color and you can also add texture to your requirement. Then what you do is, on this gel coating you try to place the fiber. So, what is the fiber? The fiber can be continuous, it can be woven, it can be short fiber. All these things, the woven and short fiber, these are in the category of mat. So, you can keep a mat, and then what you do is you place the mat exactly on top of the gel coating, and then try to use a roller, so and try to press the roller against the gel coating. So, that you are doubly making sure that there is no gap between the product and the gel coating. Then what you do is you try to apply. When you do the rolling, you also try to apply the resin into it, or you first roll the glass fiber alone and then you try to apply resin such that you have a proper contact between the gel fiber and the matrix. Then you have finished one layer. So, one layer, and then if you want to generate lot of thickness, you have multiple layers, and these multiple, here the fibers can be laid in multiple directions, or it can be many layer can be done on top, so that you get the required thickness. So, once you get the required thickness, then what do we do is we allow them to cure. So, when you try to use the matrix and when you try to push the matrix inside the fiber, you always should do it before the fiber gets into a solid state. That means to say, during the gelation, just before that you have to finish the entire operation. So, moment you finish it, then you can either apply heat can be applied, or we can do it at room temperature, allow it to cure. So, the uncured resin by addition of hardener is allowed to cure. So, once it is cured, then you can release the part outside the die. So, then what you do is you can also use ejecting pins. These are ejecting pins. So, this ejecting pins, what they do is they try to release the component, and if you are making a small component, it is easy to put ejecting pins and remove. Suppose if you are doing a very large structure, for example, something like a hull of a boat, or you are trying to do a bus front frame. So, then it is a very large part. So, here what do we do is, we also try to apply vacuum on the other side. Here we apply vacuum to have a proper hold on the other side of the component, and then we apply an ejecting pin, or again we apply a vacuum through the bottom so that it is getting released out, because it is a very large component, very large surface area. You have to be very cautious, and this is a step which it is always prone for defect or failure. Okay. This is a very critical step. All the 4 steps are straightforward, but the 5th step, when you are trying to release out, you have to be very careful. So, this is what it is. You can have a positive or a negative mold. Then you have first what you have is you put a gel coating, and then if you want to have a color finishing, you can try. If you want to add textures, you can do, and then first what you put is a glass fabric, a glass fiber or a carbon fiber fabric you just put. After placing the fabric, then what you do is you try to put resin. So, resin is getting the resin is poured on top of the fabric. So, you can use a brush, or you can use a roller, or whatever you want you can use. So, you just put the resin on top of this, and then you allow it to cure. So, moment you release out, this becomes your finished part. So, this surface is non-functional, and this surface is functional surface. So, you always worry about a smooth finish. Of course, with composites you can't make micron accuracy. We always have a liberal tolerance, maybe plus or minus 1 millimeter tolerance we allow, because the polymer shrinks, the fiber also sometimes gets slightly oriented here and there, and then so we make sure. And I have missed one point for discussion. So, here if these projections are not part of your part, then we always use operation called trimming. So, the trimming is used to remove the unwanted projections which are there. And why do we need these projections? Because these projections help during manufacturing. So, once the part is released, then we do a trimming operation to get the end product. So, same way here, after the finished product is done, then we go for a trimming operation to remove all the unwanted projections. Unwanted projections are removed. So, the sequence whatever we have seen on the schematic diagram, hand layup is mainly used for making FRP products in mold. The mold has the shape of the product. The product will have a smooth finish only on one side, so which is in contact with the mold. Only the male or the female half of the mold is generally used for. So, please understand, this is what I said, positive and negative, male, female. So, male for the hand layup. The choice of male or the female depends on which side of the product you need to have a good finish. So, first you have to decide the functional surface, and then decide which side you have to keep the, how do you place the component. In the inside, if the inside surface needs smooth surface finish, then the product is made over a male mold, or it is made on a female mold. So, this point you have to decide. How do you decide? As I told earlier, it is possible to make a product with a glossy, matte or a textured finish. This, see, finally what happens, a product is more impressive if you make it glossy. The final finish, texturing is very much talked about today, because texturing gives a big feel, improvised feel for while using the component. Texturing can be done in many ways, right, on the surface by using mold with the respective finish. The mold must be free from surface defects. This is very, very important. The mold, quality of the mold, the quality of the mold dictates or decides the product quality. If you have a poor mold, whatever precaution you take while processing, you will never be able to get a good surface finish, or you will never be able to get a quality product. So, the mold must be free from surface defects, because the imprint of such defects will form on the product. If you have any small projection, this will try to get imposed on top of the component. And apart from that, the quality, when I said the mold strength, the mold repeatability, the collapsibility, all these things are very, very important. So, as I told you earlier, so what we have made a, this is a component which is made. So, you can see here the fiber is placed and then the matrix is getting added. So, since we are making out in hand layup process, we use a brush wherein which the brush has the matrix. So, here the matrix will be, you will add ingredients. So, here it will be matrix plus whatever ingredients you wanted to add will be mixed, like hardener, UV, absorber, all these things will be added and it will be made in a liquid form. So, then it is taken from a bowl or some place and then it is just laid out. So, this is a mold. This is a mold, and on this mold they try to keep the fiber, and first they do a gel coating. This is a gel coating he does, then they keep a glass fiber and then they give a matrix coating. So, such large structures can be made and small parts also can be made. So, this is a typical example. I have worked in developing this boat when I was in my college. So, this is a complete boat. This is approximately it is not the same boat which I have developed. This I have taken it from a reference, but the boat what I developed was around about 12 meters long, which is used for fishing application. So, here if you see the top surface is, we are not worried about surface finish. The bottom surface it's very smooth, we get it, and here is a mold. This is a mold. Okay. So, this you can have on this supporting structure, inside you will have a wooden mold made or wooden pattern made. So, then on top of it you try to do it. So, these are the projections which are because of the fiber. So, they are all trimmed before giving to the customer. So, the first layer of the mold is a gel coating. Before gel coating you have to do a degreasing and then you have to put a greasing. See, for example, whenever we do a cake cooking, we always put a butter sheet. So, this butter sheet's prime responsibility is to make sure that the cake does not stick on to the basin. So, in the same way here we try to do a release coating and then we try to do a gel coating. So, the gel coating gives you a very good surface finish. A release film is used to avoid the mold from getting stuck. So, then we try to use a woven fabric, whatever I discussed earlier. Then we form several layers. It is not one layer, there are several layers depending upon the thickness. The resin is mixed with some catalyst to introduce the hardness to the composite. It is like cooking. So, depending upon the taste, depending upon the performance, whatever you want, the component can be, the ingredients can be added to it. A brush is used to spread the resin. The roller is used after laying each layer to remove the air trapped in the resin, and it also tries to remove the excess resin. So, that you do not get, see, generally what happens, excess rich resin means you will have at certain pockets there will be more resin there. So, when the resin is added more, it becomes, the part becomes heavy. So, they will always make sure that the air gap is removed so that you get a better performance, and the excess resin is removed such that the weight is reduced. The process is repeated until you get the required thickness. The resin used requires curing for the hardening of its liquid to form into a hardened product. So, that is what I said, all the ingredients. The curing at room temperature. So, the curing can happen both at RT as well as at elevated temperature depending upon your requirement. When it is a large size product, it is always done at room temperature only. And here it is, you can use epoxy resin, you can use polyester resin depending upon your requirement. So, the gel coating is a thin layer of resin applied over a release film. So, the gel coating gives a superior finish. The important function of this gel coat is only to give a superior surface finish. So, the gel coat serves the following purpose: it provides color, glossiness and texturing of the product. It conceals the fiber pattern. It also provides a resin rich layer that protects the fiber from getting in contact with water and chemical. So, that means to say, I make the glass fiber and then I have a very small layer of gel coating. Okay. This will try to protect from the service conditions. So, this is a service condition. So, this is nothing but a gel coating, and this is a composite, and we are discussing about GFRP. Okay. This is how it is. So, this is what we have said. It also provides a resin rich layer that protects the fiber from getting in contact with water or chemicals. This is a service condition. Service condition can be water and other water, humidity, and then chemical etchingness. So, what are the major advantages? Sir, it can make a small part, it can make a very large part. Very large part where in which it is complex in nature. So, large scale product which is complex in nature also can be made. It is a very non-expensive process because there is no equipments which is required. All you need is only a pattern, then all the other things are brush and rollers and very trivial items. Practically there is no restriction on the size of the product. That is the biggest advantage of this. Big structures, very big structures where in which it does not have for structural applications, very big structures, only if giving form it can be used. It is possible to mold all shapes and incorporate inserts of any shape. This is what I said is the flexibility of the process. If you want in between 4 or 5 layers, you want to keep a metal strip and reinforce the composite once again, depending upon your requirements. Or if you want to put a mesh, or if I want to put smart sensors to monitor what is going on. For example, in marine applications, the submarines are they are all, the shell of the submarine is made out of composite, and they wanted to do monitoring of the process, what is the heat getting generated very close to the motor. So, they try to embed all these sensors. So, this is possible by this process. Depending upon the end user's taste, color, decorative finishes can be done. This is the most suitable method for lining of tanks, ducts, boats, and repair of concrete. So, this process can also be used for repairing. See, what has happened is the thermoset composites which came into the market before 50 years. Now, slowly the matrix has got deteriorated. So, moment the matrix is deteriorated, the reinforcement is now getting exposed to service conditions. If you want to repair those parts, then we use hand layup. Repair by hand layup is very common. Repair by hand layup process is very, very common. There is a limitation. First thing is the process is labor intensive, and the quality of the product predominantly depends upon the skill of a person. While doing this process, there is lot of toxic gases are also getting released. So, it is little hazardous for the operator or for the labor who is involved in this process. And if you make very large structures, releasing of a large structure really needs skill, and this has to be planned while making the mold itself. The process is not suitable if good surface finish is required on both sides. That means to say, if you want both sides surface finish, you need to have a female die and a male die, and then it becomes a closed mold process. But here it is an open mold process. The process cannot compete with compression molding for mass production of small items. So, this process is only for large and complex geometry. The thickness control cannot be very accurate. It depends upon the resin to fiber ratio. So, that means to say the volume fraction decides the thickness control. So, that is why I said non-functional surface dimensionally will be very liberal. We will say 3 millimeter tolerance is okay for me, or 2 millimeter tolerance is okay for me. If you see as such also in a boat, the internal the internal surface here, the internal surface, you do not need to have a very good surface finish or a dimensional tolerance, but yes, so outside you need to have the proper profiling and other things. This tries to take care of your drag. So, the next process of discussion is going to be spray layup process. Spray layup process is almost the same like that of your hand layup process, but the only thing here is we will try to use a long fiber, right, a long fiber, and this long fiber is allowed to pass through a nozzle wherein which it is chopped and then it is sprayed. So, it is chopped and then it is sent. So, you have the resin which is mixed along with the catalyst comes through this hopper, and then the fiber comes through here and it is getting chopped. So, this two gets mixed. So, there is a mixing chamber. This mixing chamber design is very, very critical, Why? Because there has to be a optimum gas pressure versus fiber cutting. Okay. So, fiber cutting. So, this two gets mixed here, and then once it is getting mixed, then what you do is we try to spray it. So, it gets mixed and then you try to spray it. So, there are two ways of doing it. It can be done inside the mixing chamber, or it can be done outside the mixing chamber. People generally try to do it inside the mixing chamber so that you get a controlled product. So, here the process is the same. It is a open mold, you have an open mold. Okay, this open mold is given a gel coating. As I told, this gel coating decides, this gel coating is acts in between the product and the mold. Okay. This gel coating will exist in the final product. So, then what do we do is then we try to spray the part. So, what is the advantage here? Wherever you had a sharp corner, for example, a star, these are all sharp corners. So, in sharp corners, trying to push the glass fiber at extreme edges, at these edges, is very, very difficult. So, you will always try to get, if you use a hand layup process, you will get a radiusing. In order to avoid this radiusing, what we do is we try to use this spray layer process. So, spray layer process, wherever there is an intricate part, so the intricate geometry, this process, the air is at a high pressure. So, this polymer gets mixed with air. So, then they try to go and occupy the sharp corners to get the required product. Rest all is the same. It is an open molding process. So, here one side you get a good finish, the other side you get the unfinished or semi finished part. So, here the spray is another low to medium volume and a open mold process. Here the production is higher than that of the hand layup process. So, greater complexity in terms of sharp corners. Sharp corners can be made using this process. In the spray laying process, a chopped fiber and resin are simultaneously deposited on the open mold. Right. Usually, glass fiber rovings are used in the process. The glass fiber roving are fed through a chopper. So, that means to say you will have two wheels, fiber comes in between them, and then what you do is you try to have something like a chopper which passes through it. It tries to chop and then try to make several small fragments of the glass fiber. So, the glass fiber roving are fed through a chopper and propelled into the resin stream, which is directed towards the mold. So, I said mixing can happen both inside a mixing chamber and then it can spray, or it can only just cut and move forward, resin comes and gets added in between. So, the spray gun consists of two nozzles. One nozzle sprays resin pre-mixed with the catalyst or the catalyst alone, while the other nozzle sprays the resin pre-mixed with the accelerator. So, you see now I have talked about two terms. One is called as an accelerator, catalyst. So, accelerator and catalyst are predominantly used for enhancing the curing process. So, the resin mix pre-coats the strand of the glass fiber, and the coated fiber with the resin is sprayed onto the mold in an even pattern by the operator. So, basically what you do is the operator tries to take a gun and he goes around at the sharp corners and fills it up, and and here also what happens is he uniformly tries to fill it up. If he does not uniformly do it, then at certain patches you will have rich fiber reinforcement and rich resin mix. So it becomes very difficult, and the biggest challenge here is the coating that means to say the wettability between the fiber and the matrix has to be done proper. So the interface has to be proper, otherwise the quality of the product is not good. So the resin mix pre-coats these strands of the glass fiber. The resin mix pre-coats the strands of the glass fiber, and the coated fiber with the resin is sprayed on the mold and in an even pattern by the operator. So it is also a skilled process depending upon the operator. If you look at it, look at this, a dome. This is a man, so it should be almost his size or slightly larger. So this dome is being completely made out of composite. So it is light in weight and it is used for applications. So you can see here the operator goes around holding the nozzle. So this is a nozzle. So you can see here a nozzle. So the nozzle consists of two. One is for resin, the another is for fabric. So here you can also have combinations, sir. You put all these spray coating in the first region, and then you can also try to have hand layup. So hybrid processes are followed today. So that means to say hand layup and spray layup are mixed also to get the required output, required thickness, right. So you can always have a hand layup and this is process. Hybrid process are followed, hand layup and spray layup are mixed to get the required output. So if you look at the features, salient features, or if you look at the importance, if you want to understand which process to choose. So here size, these two process size is not a restriction at all. You can make very large parts. Very small parts people don't do it because it is very difficult to do small parts and then get removed and other things. So it is used for very large size. Part geometry can be very simple to complex. For example, the shell, which I have shown you as an example, is a simple structure. Boat, when you look, it is slightly complex. You can also have aerospace components. The production volume can be always low to medium. That means to say we are not expecting more than 100 per year or 1000 per year. So this is the numbers typically we are looking at it. The cycle time is very slow. It takes, sometimes if you have a very large component, it takes several days to form, right. And if you have a very large component and using a roller is not a good idea. So what generally people do is on assuming this is a hull, since I worked on it, I have got exposed. So we always used to put here tubes pressurized with air, so that this tries to butt against the fiber and this will try to butt against the mold to get the required smooth output. Okay. Surface finish can move from good to excellent. Tooling cost is very low. Tooling equipment cost is also extremely low. So this process is most welcome for low part volume production with complex geometry. So we are done with today's lecture. So I would like to give you an assignment. So you try to have a look at 15 different parts of your choice. Let it be a glass, let it be made out of the part can be made out of ceramic, polymer, it can be made out of metal. Choose 15 different parts and try to identify which are all the functional surface and non-functional surface. Moment you identify functional and non-functional surface, now you go to the next step and decide whether to go for open molding process or a closed molding process. Open molding process, you will use the male part or the female part, male side or the female side for producing it. Only one side will be predominantly used for making. When it is closed, we have something like a male and female put together, maintain a small thickness, we try to make an output. So with this we have finished the first two basic processes of thermosetting glass fiber reinforced plastic composites, open molding and closed molding process. Thank you.